So I wish to start by explaining the difference between dimensional and relational model. So according to Steve Hoberman in his book Data Modeling Made Simple, the distinction between the two types of model is relational data model captures the business solution for how part of the business work. That is all including the business process. Whereas in dimension data model captures the details the business needs to answer questions about how well it is doing. The relational data model includes the entire business process. There is, the transactional activities of the business, which includes insertion, updation, deletion, and selection. However, in the dimensional data model, the focus is on selection, getting what is required from the database. Of course, there is insertion, there is updation, but that happens only during certain intervals. And that can be a little costly. But you define the dimensional data model in such a way that your queries returns the result in an efficient way. It's more focused on selection. So some of the characteristics of a dimensional data model, all the foreign keys are in one place, that is in the fact table. There is no dimension to dimension join. In an ideally designed fact, carry only numbers, measures, or foreign keys. There is no description at all. Dimensions are used to carry description and non-aggregable info. Then redundancy of data is ignored. The tables are denormalized, unlike in the relational database. The dimension modeling is a data warehouse design methodology used to simplify complex databases. This methodology structures data into fact. And what is fact? It is something measurable data. So the fact table contains measurable data and dimensions. These are basically the dimension tables. So we have fact table and we have dimension table. What's the use of a dimension table? It is a contextual or descriptive data. So remember that in the fact table, we are storing the measurable data. In the dimension table, we are storing descriptive or contextual data. What's the purpose of this? That is at the end of this definition, which is called it enables intuitive, high-performance analytical queries. Already I mentioned that the dimension model focus on selection, isn't it? So dimension modeling is a data warehouse design methodology used to simplify complex databases. This methodology structures data into fact, which is measurable data, and dimensions. It's a contextual and descriptive data to enable intuitive, high performance, and analytical queries. Hope you understand that. Let's move on. So in dimension model, there are two types of tables, fact table and dimension table. Okay. Look at the diagram, you can understand it is basically the central, that is a fact table. Then we have other dimension table related to the fact table, right? The fact table is carrying foreign key relationship from the dimension tables. To understand fact table, few points. A fact table sits at the center of the dimensional model containing numeric measurements, facts of the business process, sales value, quantity sold, etc. We will see that with example. The fact table often include foreign keys referring to associated dimension table. So we have the store primary key. This primary key become a foreign key in the fact table. So that also we will see in the later stage. So what is the dimension table? When fact table carries only measurable data, of course, the dimension table should carry the descriptive data, right? So dimension table contains descriptive attributes that help define the fact stored in the fact tables like product name, location, date, customer details, etc. So here in the product table, we will have product ID and product description, product location and all. Then here we have the sales order. It carries who is the customer and the quantity. All those things are carried in the sales order. Then we have the data like the day, month, quarter, year, and so on in the date period. And we have the customer information in the customer dimension table. So dimension offer a user-friendly structure enabling people to navigate to the data intuitively. The major two components of any dimensional model is fact table and dimension table. And fact table carries the measurable fields and dimension table carries the descriptive part of it. Then very interesting to understand what is the granularity or grain. So granularity refers to the level of detail in a fact table. It is often the first aspect to be determined when building a fact table. So when you extracting a report from the data warehouse, you will have an idea about to what level you need the details, right? That is what is called the granularity or grain. The granularity can be desired based on the requirement of the business process. Okay. So grain refers to the finest level of details that is implied when fact and dimension tables are joined. It is a combination of the columns at which records in the table are unique. So you can see that the fact table, you have the product key, we have the time key, we have the customer key, we have the sales region key, and we have the measurable fields like unit sales and sales dollars. We will have more columns later to the calculated columns showing the sum of the sales and so on. So as per this definition, the grain is the finest level of details that is implied when fact dimension tables are joined. Okay. Hope you understand the granularity or grain in a dimensional modeling. There are mainly two schemas usually adopted in the dimensional modeling. That is, one is star model, right? So you can create a star here, right? This is the star schema. The star schema, named for its resemblance to a star. This schema has denormalized structure with a fact table in the middle, surrounded by dimension tables. Each dimension table is connected to the fact table using a primary foreign key relationship. You can see the center is a fact table, and there fact table is connected to dimension table. The primary key of the dimension table is the foreign key of the fact table, and this combination of the foreign key makes a unique key in the fact table. So that is the star schema. It's very easy to understand, very easy to remember. You have the fact table in the center and all the dimension table surrounded by the fact table. And you remember the fact tables carries the foreign key from the dimension table, and that combination of the foreign key makes it as a unique key. Okay, that is the star schema. So now going forward, we have very important schema in the dimension table, which is nothing but the snowflake schema. Again, this is little more normalized when compared to the star schema. You can see some more additional connections, right? Additional links. So what is the star schema? What is the snowflake schema? This is more normalized version of a star schema, in which the dimension tables are further broken down into smaller normalized tables. While potentially saving storage space, this approach can make queries more complex and slower. Yeah, because there is a location, right? There is a location, and the location has a city field. And again, the city field carries a foreign key. And again, there is a dimension table for city, right? So, unlike the star schema which you just saw, there is no second level, but you can see a second level for the location. And here also, under the item, you can see a supplier key. Again, supplier has a dimension table. So it is more normalized than the star schema. And because of that, it can be more complex and slower because there should be a join between the dimension tables. So if you ask which is better, which is more followed, that is the star schema than the snowflake schema. Okay, we'll try to see how to implement star schema and snowflake schema using the Erwin. Of course, because of this schema, there are many advantages. So one is it is the intuitive. The structure of the dimension model is quite intuitive, allowing end user to easily navigate and understand the data. Of course, from a performance point of view, it is much faster because due to the denormalization, the number of joins in a query is minimized, leading to a high performance query execution. And it's very flexible. It can easily adapt to changing business requirement. The dimensional modeling is widely accepted for its ability to deliver data in a format that is easy to understand for end users, providing a foundation for efficient analysis and reporting. From a theory point of view, I think this is more than enough. So without delay, let's get into the Erwin tool and try to build a dimensional data model, especially the star schema.